Section 4.2, Natural Exponential Functions, Part 4. The population of a certain species of bird is limited by the type of habitat required for nesting. The population behaves according to the logistic growth model as follows, where T is measured in years. Find the initial bird population, draw a graph of the function. What size does the population approach as time goes on? So let's go back and maybe reread our problem. Sometimes you might have to reread these a couple of times, but our reread, what we want to identify is what our variables represent. This one's an easy one where T is measured in years. That's clearly stated. When we come back here, the population behaves according to this model. So this model represents population, and this is a population of birds. So number of birds. Find the initial bird population. So we're finding N. Draw a graph. What size does the population approach? Those are questions that are going to now be solved. Okay, let's start with Part A. Part A, find the initial bird population. So initial is a key word that we can associate with 0. At time 0, what was the population? What was the initial population? In our formula, we're going to go ahead and plug in 0. So we get 5,600 divided by 0.5 plus 27.5 e to the negative 0.044 times 0. We'll grab our calculator. Normally, we would just go ahead and plug in these values, but I'm going to approach this one just a little bit differently. I'm going to go right into y equals for the graph. I'm going to put in the equation. I know I'm going to have to graph it and see what the population approaches. So that's going to involve graphing. And then I can either say second value 0 to get my value for part A, or we can go into table and get our value for part A. So we'll save ourselves just maybe a little bit of time by just going right to the graph, and we're going to plug in our equation. So 5,600 divided by 0.5 plus 27.5 e to the negative 0.044 x. Okay, second zoom standard is where we usually try to start. Second zoom standard. This marking here tells us our calculator is still working, kind of that it's called a worm, still working, and then we see nothing, not because we put the equation in wrong, but because our scaling isn't good for this equation. Okay, so let's go into table, and if we go into table, what we see is after 36 years, we might have a population of, say, 900 birds. We kind of come back. What was our population at 0 birds? Population at 0 birds was 200. Okay, so here we can say the initial population at time equals 0, we have 200 birds. Okay, so let's go back to our graph and see if we could scale it to see if what our population approaches. Okay, so we're going to hit graph. We're going to go to window. In table, however, I wanted to point out that What we can do for the x-axis is 0 to something. Notice the y values already start out at that 200, and at 200 they just get larger and larger and larger. So what I'm going to try to do is, let's maybe go to 1500, and let's see if that's good enough. If not, we'll just come back and try again. Okay, so we'll go, time is the x-axis, so I'm going to put -1 so I see a little bit of the axes, and then we're going to go to, say, 50 years. Each tick mark is going to be worth 10, 10, 20, 30, 40, 50 years. Okay, on the y-axis, we were thinking 1,000, so we'll go to 1,000, and each tick mark we're going to let represent 100. Let's hit graph. If this isn't a good graph, we can always go back and change it. Okay, it doesn't look like we are approaching any certain number, so let's go back to window and let's let x go to, say, 100. We'll double that, and then y will increase to maybe 5,000. Let's see what that does. Each tick mark will be worth 1,000 units. We'll hit graph. Let's see if we're looking for what the population approaches. We're hoping to see that, maybe that leveling off. Okay, so it looks like we're going to have to go a little bit further. And at this point, I just want to check my equation, make sure I put it in right. 5,600, parenthesis around the entire denominator. Parenthesis around the entire denominator. Shoot. Yeah, no, there we go. 0, -0.044. Okay. Yeah, looks all right. Okay, so let's just see if we could get a better window. Maybe it doesn't approach anything, but they're asking us that question. Let's see if we can explore more. All right, well, let's go to 200 on the x-axis and maybe 10,000 on the y-axis. We're looking for that leveling off. All right, kind of seeing a curve backward. So I think we're making progress slow, but we're making progress. All right, then we'll go to 500. Each tick mark worth 100. And then let's see, let's go to, say, 30,000. Each tick mark is worth 1,000. We'll hit graph. There we go. Finally, we see the population leveling off, and now we want to see what value it approaches. If we hit trace and focus on the y, we're at 11,189, 11,200. I don't think we're getting much bigger than that. I'm going to say 11,200. So now we're starting to focus on building up the 0.9, 0.99, 0.999. So this value is approaching 11,200. All right, let me grab this graph. I'm going to go ahead and put that in our video notes. We're going to size it so it fits. All right, so there's our graph for part B, and then part C. What size does the population approach as time goes on? We're starting with 0, and time goes on to, say, 500. That's what we did, but we're still thinking even beyond 500. So as time goes on, as time increases, is there a certain value that this approaches? And what we could see graphically, it approaches 11,200 birds. Okay, that finishes off section 4.2.